Hello student, welcome once again to Peko Virtual School, a school where learning takes place at home. My name is Wanda Ronald, your teacher for physics. Dear student, we have looked at a number of things in our previous lessons for those who enrolled under this program. And the topic we've been handling is measurements in physics, and we have looked at how measurements can be taken with different or on different physical quantities. We've looked at length, volume, area, mass, and time. And you know what you need to use or how to determine those physical quantities. Now, today we look at yet another measurement in life, and that is the density of a substance. Density of a substance. In this subtopic of density of a substance, you are expected to attain this competence. In this section, you will learn a more convenient way of comparing objects and why it is important to compare objects using the concept of density. You will also relate density to floating and sinking of objects by the end of the subtopic of density of a substance. So make sure that you have mastered this at the end of it, of the subtopic density of a substance. Now, what is the meaning of density? I know from your primary level you have defined density, but I will go quite slowly for us to understand what density actually is. I bring you a picture there with different objects. There's a loaf of bread there. There's a brick. There is a ball. Footballers, I know they are now excited. And there is a bottle containing water, and there is a stone there, or a metallic mass there. Now, density. What do we actually mean by density? Do we mean which object has the greatest mass, or which object has the most amount of matter? You remember we looked at mass and we said that this is the amount of matter in a body. Now when you talk about density, are we meaning the mass, or the what is it contains? Does it have much amount of matter? Or do we mean which object has the greatest volume? Or in other words, which object takes up the greatest amount of space? Is that what we actually mean? Okay. Those are some of the questions that I've just posed for us to try to understand the concept of density, or what density actually means. Bringing back our picture, some of the objects in this figure here have a small mass but a large volume. In other words, some have more matter contained in them, but they occupy a large space. In other words, they have a large volume. Whereas, for example, a ball ball like this one here, you can see it is occupying a lot of space compared to this brick here or compared to this stone here, but it has a low mass. Its mass is small. The brick, however, has a large mass but a small volume. It is occupying a smaller area. Or look at this stone here. It has a large mass, maybe heavier than all of these, but yet it is occupying a small area. So we say that the brick has a large density, but the ball has a small density. So a body which has more matter but occupies smaller space. Okay? A body which has more matter, more amount of matter, but occupies a very small volume is the one which has a large density. So from that analysis, what is density? What is density? Now, density is simply defined as the mass per unit volume of a substance. The mass per unit volume. The word unit here simply means one. Or we can say the mass of 1 centimeter cubed of the substance. The mass that will occupy 1 centimeter cubed of the substance is what we call the density of the substance, the mass per unit volume. Okay, what are the units of density? What are the units of density? The units of density will depend on the unit you use to measure. We have looked at density. It looks at two things, as mass and volume. So the unit of density that you will get will also depend on what unit you have used for mass and what unit you have used for volume. Mass and volume. If you measure the mass of a substance in grams and the volume in cubic centimeters, then the density will be in grams per cubic centimeter. In terms of symbols, grams stroke centimeters cubed if you're old fashioned, but if you're new fashioned, then you write it in this form: grams cm to the power negative 3, meaning grams per cubic centimeter. So this unit, you got it, or you get this unit when the mass is measured in grams and the volume in cubic centimeters. But what is the SI unit? The SI unit, or the standard international unit of density, is kilogram per cubic meter. Kilogram per cubic meter. Of course, the SI unit of mass is kilogram and the SI unit of volume is meters cubed. So kilogram per cubic meter, written like this or like this one here. And that is the SI unit of density. So we want to understand what the SI unit actually means. So the density of water, for example, is 1 gram per cubic centimeter. 1 gram per cubic centimeter. It simply means that 1 gram of water will occupy 1 cubic centimeter. 1 cubic centimeter, or 1 centimeter cubed of volume. Now the density of copper also is 8.9 grams per cubic centimeters. That simply means that 8.9 grams of copper occupy 1 centimeter cubed of the volume, or of the space around that mass. So that is what the unit of density means. 8.9 grams per cubic centimeter. It means 8 grams occupy 1 centimeter cubed, or 8.9 grams occupy 1 centimeter cubed. But it can be in standard unit, like for example for water, again in standard unit is 1000 kilogram per cubic meter. 1000 kilogram per cubic meter here. So this means that 1000 kilograms of water occupy 1 meter cubed, or 1 cubic meter of volume. That is what the unit of density actually means. So I hope you don't just cram this unit, but what it means is that amount of mass occupied this 1 cubic centimeter of volume, or 1 cubic meter of volume. Okay, now how can you convert these units of density? So let's look at conversion of the units of density. For example, we have seen that the density of water is 1000 kilogram per cubic meter into grams per cubic centimeter. Now we have our 1000 there. Now this simply means that 1000 kilograms over 1 meter cubed. 1000 kilograms over 1 meter cubed. So we have to convert the kilograms to grams and the meters cubed to centimeters cubed. Okay, so how do we convert that? Now we know that 1 kilogram is equal to 1000 grams. 1 kilogram, you remember the units of conversion in mass. 1 kilogram is equal to 1000. Now if I have 1000 kilograms, then I have to multiply by 1000 so that I get this 1000 times 1000 grams. Now you also remember that 1 meter cubed is the same as multiplying 1 meter times 1 meter times 1 meter 3 times. 1 meter times 1 meter times 1 meter 3 times. So here, so in terms of centimeters, this would be 100 centimeters times 100 centimeters times 100 centimeters 3 times, and therefore that value there again, when you multiply that becomes 1 million, and also here when you multiply you get also 1 million centimeter cubed. Centimeter cubed, we're converting this to centimeter cubed. So when you divide, you can see 1 million divided by 1 million, we shall remain with, that gives us 1 gram divided by 1 centimeters cubed, so giving us 1 gram per cubic centimeter. So therefore, or hence, 1000 kilograms per cubic meter is the same as 1 gram per centimeters cubed, simply written, or 1 gram per centimeter cubed is 1000 kilograms per cubic meter, on the other way around. So for copper, with the density of this, how can we convert to kilogram? We just have to multiply by 1000. 8.9 times 1000, and our value will be 8900 kilogram per cubic meter. So to convert from grams per cubic centimeter from this unit here, to convert from grams per cubic meter, this unit here, to kilogram per cubic meter, you just have to multiply by 1000 like I've done here, and you get 8900, and vice versa. To convert from kilogram per cubic meter to you just have to divide. So now here, if I have density of gold which is 19,300, I want to convert grams per cubic centimeters, then I just have to divide this value by 1000, and then I get therefore 19.3. Good, 19.3 grams per cubic centimeters. So when you are converting from kilograms per cubic meter, which is this value here, kilograms per cubic meter, to grams per cubic centimeter, then you just have to divide and you get 19.3. So that is about conversion. You will get an exercise on that, or you can try out some numbers about conversion of units of density. Now let us look at comparing substances with the same volume. Comparing substances with the same volume. I have here different substances, a picture showing different substances, but when you look at this box here, it's of the same size. When you have gold, copper, steel, water, wood, hardwood for example, paraffin, and milk. When you look at these, all the cubes have the same volume, but they all have different mass. They have the same volume, but they have different what? Mass. Look at water. It has just 1 gram. Look at gold. It has 19.3 grams. But look at milk, 1.03. Paraffin, 0.8. So the lightest cube is 1 centimeter cubed of paraffin. When you look at these cubes, paraffin wax and wood, which have 0.8 and 0.8, which has a mass of less than a gram, which is 0.8. But the heaviest cube, as you can see from the diagram, is gold with 19.3 grams. So you can see why gold is needed or is admired, which has a mass of more than 20 times the mass of paraffin. Even if you get 20 times 0.8, you will get just 16. Gold is 19.3. So it has a high density, a lot of amount of matter in it, which occupies a very small space. So we say that gold is denser than paraffin. It is occupying the same volume, but it has more mass. So gold is denser than paraffin. Okay, that was just compare. So now let's look at some of the values or the density of some common substances which are around us or on the market. I'm starting with this metal called aluminium. Aluminium has a density of 2.7 grams per cubic centimeter. If you want to change to kilograms per cubic meter, remember you just have to multiply by 1,000. Then gold, that one we have already known that. Okay, we have 10.3. That type of gold is 10.3. Then you have wood. The density of wood is just 0.6 grams per cubic centimeter. Coke is lighter than wood, 0.3. It's less dense, 0.3. Glass, how about glass? 2.5. Glass is a bit more denser than wood and a coke. How about mercury? That's important mineral there. Mercury has a density of 13.6 grams per cubic centimeter. 13.6. We're going for, how about copper? That color there. This is copper here. What is its density? Density is 8.9 grams per cubic centimeter. Again, steel has a density of 7.9 grams per cubic centimeter. And how about paraffin? There it is poured in a beaker there. As you can see, this is paraffin, that color there. It has a density of 0.8 grams per cubic centimeter. Okay, so these are some of the materials that are used commonly in our structures, and that is the value of their densities. That's their values of the densities. Okay, now let us now look at the density, or the formula for density. Of course, from the definition, density is the mass per unit volume of a substance. But how do we get it? It simply means get the mass of a substance divided by the volume of the same substance. I want to emphasize this, the volume of the same substance, because even if you get the mass of a substance and divide the volume of another, you will get a value, but that will not be the density of that same substance. So the formula is mass over volume, but remember, it should be of the same substance. So the symbol for density in physics is a Greek letter rho. I know from your primary you've been using D as the symbol for density, but I want to ask you, dear students, that you adjust to these scientific letters, these Greek letters which are used in the scientific subjects like physics, biology, chemistry, and we shall prefer that you write this letter which looks like P but not a P. It is called rho. Practice how to write this, and that's the symbol. So since we've said density is mass of volume, we can now write our symbols. Rho is equals m over v, where the m is the mass and v is the volume. Now if we want to make the mass the subject, definitely you know that I will cross multiply and I'll have mass as density times volume. So m is rho times v. And also, if I'm to make volume the subject of the formula, then I will divide here by density, and therefore volume is mass over density. Mass over density. Okay, for you to easily remember this, I have put here a triangle which helps you to master the formula. And then in this graph we have density rho is given by mass, which is up here, over volume. The density is mass over volume. Okay, if I want to get mass, then this mass here is density times, which are on the same level here, density times volume. And if I want to get volume here, it is mass over density. That triangle there gives us a summary of the three formulas in one. The three formulas in one, and you'll be able to recall that formula very easily. Let's look at an example, or examples. Let's look at a wooden block of mass 200 grams is 4.0 centimeters wide, 2.5 centimeters thick, and 1.0 centimeters long. Calculate the density of a wooden block. Very simple, that one. Solution: what is the mass we are given? Is 200. We have been given 200. And what is our volume? Since we have given the length, the width, and the thickness, or the breadth, then we have L times W times H, and we just substitute 4 times 2.5 times 1, and we get V is equal to 10 centimeters cubed. Now this is our mass, and this is our volume. So what is our formula? You remember, density is equal to mass over volume. So divide the mass 200 by 10, and we shall be able to get 20 grams per cubic centimeter. 20 grams cubic centimeter. Now, the unit is grams per cubic centimeter because you have mass in grams and you have volume in centimeters what? Cubed. Good. Let's proceed to our second example. Determine the density in kilograms per cubic meter of a solid whose mass is 40 grams and whose dimensions are 30 excuse me 30 centimeters by 40 centimeters and by 3. So the mass is given as 40. Mass is given as 40, and the volume, the dimensions are given. We are going to use our formula of volume. You remember, L times W times H, giving us 30 times 40. 30 times 3, giving us 360 centimeters cubed. So when we divide the mass over the volume, this value should be 4. We shall have 0.1111 grams per cubic centimeter. But now they wanted the value in kilograms per cubic meter. What do? We multiply by 1000, and the answer we get is 111.1 kilograms per cubic meter. Okay. Another example, the figure below shows a measuring cylinder which contains water initially at level A. When a solid of mass 45 grams is immersed in water, the level raises to B. Determine the density of the solid in kilograms. And this is the figure. So there is A initially, then there is B. Remember how we read the volume of a liquid in a measuring cylinder. So in our solution, our mass is 45. Our volume is, we shall read the volume here, volume at B minus the volume at A. The volume at B, which is, now if we were to look very well, this is 30, 31, 32, 33 bar. It is, you read at this point, but you don't read here. You read at this what? Lower meniscus, at the bottom of the meniscus of a liquid. Then when you look at at B, again at the bottom of the meniscus, this is 40, 45, 46, 47, 48. So you have, say, 48 centimeters cubed. You can see the unit here is given, minus 33, and this value is 33. So we get the volume to be 15 centimeters cubed. So when you substitute in our formula, mass over volume, 45 over 15, we get 3 grams per cubic centimeter. But again, to multiply by 1000 so that it is in kilograms per cubic meter, we get 3000 kilograms per cubic meter. Good. Now, how do we, having understood the meaning of density, the units of density, some densities of densities of some substances like aluminium, gold, wood, glass, water, and having known how to calculate if you are given the mass and the volume, how do we then determine experimentally the density of a substance? Determining the density of a substance. Now, the activity, determine the density of a wooden block. From what we have learned, I think you can determine the density of a block, like for example brick. Obtain a wooden brick, a wooden block, and a brick. We're going to have two things, the block and the brick. of nearly equal size. A wooden block and a brick. Wooden means it is made of wood, but this one is these bricks they use to construct. So obtain or have two of them of equal size. Measure the dimensions at home there. Remember how we measured length and calculate the volume of each in centimeters cubed. And then measure the mass of each. You know what to use because we've studied how to measure mass. And then determine their densities. Compare the densities, dear student, of the wood and the material used to make the brick you have measured. After you have determined their densities, compare which one is greater than the other. Then you will know which one is more dense or denser than the other. In another activity that you need to do at home there, dear student of senior 1, is to determine the density of liquids. Now, we want to compare. So obtain 1.5 liters of milk and 1.5 liters of water. Okay, measure the mass of the milk and the water obtained above. Determine the density of milk and the water. Compare their densities. You will find which one is denser than the other. Which one is denser than the other? How will you get 1.5 liters? You know how to get 1.5. Look for something which can measure either a half a liter and make 3 times, measure 3 times, and then obtain the mass of that water and milk and compare. So what are the factors that affect density of a substance? Of course, from the formula you saw that density is equal to mass over volume. So the mass and the volume are the two factors which affect, but there are those that affect density. Now let's look at the concentration of atoms in the substance and the temperature. The concentration of atoms, you know that all matter is made up of moving particles. In solids, liquids, and in gases, the particles vibrate. Rather, in solids, the particles vibrate about some point, but in liquids and gases, the particles can also move around. They keep moving randomly around. So now, the amount of atoms, you also notice when substances are heated, the particles move faster and need more space to move. Now, when this solid here, which has particles which are packed, but when it is heated, there will be separation, and therefore they will require more space, meaning increase in volume. Meaning increase in what? In volume. So the substance expands, and when the substance expands, if its volume increases, rather its volume will increase, then what will happen to the density? Okay, if the volume of substance increases but its mass stays the same or constant, its density decreases. Its density decreases. So when a substance or when substances are heated and they expand, their densities therefore do what? Decrease. An increase in volume will mean a decrease in density, and volume can only be can be increased by heating the substance such that it expands. Okay, when substances cool down, the particles contract, and the volume they occupy will decrease. Hence, therefore, an increase leading to an increase in the density of that substance, leading to an increase in the density of that substance. And therefore, solid state of a substance is denser than the liquid. So you find solids being denser than, because the atoms are concentrated together, they are packed together, which in turn make it denser than gases. Okay, yeah, let us look at the applications of density, and this is in relation to floating and sinking. If we drop a piece of steel, a steel rod, into water, what happens? It will sink to the bottom. Why is it so? Why does it sink? So we want to look at, understand why objects sink. So, comparing densities of substances with that of water, the key question is, why do some solids sink in water but others float? Why do others just stay on top? What you need to do to discover some different solids, such as you need to have a piece of metal, pieces of metal, you need to have plastic material, you need also to have wood, and try to compare which one will sink and which one will float. Okay, what to do? Take different solids and put them in water, observe whether they float or they sink, measure their mass and volume, calculate their density. So after you have put in water, check whether it floats or it sinks. Then afterwards, you measure their mass and their volume, which will help you to calculate their density. Compare the densities of each with that of water and make a comment on your answer. Those substances with a density of less than that of water, you will realize that they float. What can you say about the substances of the objects that sink? You will realize that they have a density greater than the density of water. Now, with that concept of floating and sinking, there I bring you a picture of the fishermen. These boys here are seated in a canoe. Okay, now that boat there floats. The ship there floats on water. However heavy it is, it floats. So we're going to understand why. Now, people living near water bodies like Lake Victoria or River Nile use canoes made out of wood. The canoe is able to float on water. Why? Because on average, the wood is less dense than water. The ship is made of steel and weighs about 105,000 tons, but it can't float. Why? It can't float on water. Why? The ship is made of steel, but inside it there are many other things, including air. This steel it is made of is hollow. Air has a very low density, so on average the air and the steel together have a density that is less than or smaller than 1 gram per cubic centimeter, which is the density of water. So as this is less than the density of water, the ship will float. Okay, the ship will float. Floating in the sea, the density of seawater is greater than the density of fresh water. Why? Because of the salt dissolved in it. Seawater has salt and therefore it has impurities, making the density of seawater to be slightly more than that of fresh water, which is just 1 gram. This is 1.03 grams per cubic centimeter. So try the next activity that uses seawater and see if you can explain your observation. So compare how much an object sinks in seawater and in fresh water. The key things question that you need: deep how deep does a block of wood float in fresh water and in seawater? So we are going to try that. What you need small block of wood, you need a barrel, then what will you do? You will need water, okay? You also need salt, okay? So what will you do? Put some water in the bowl, float the block of wood in it. Make a mark on the wood where the water level is, or where the water level reaches. Then make some salty water that will be like seawater by dissolving some salt in the water, and then use quite a lot of salt in this experiment. Don't use very little. Float the same block of wood in your salty water and then mark the level of water on the wood. Were the two levels the same? That will be the question you need to answer. You will have found that or you will find out that the block of wood floats higher in salty water than in fresh water. This is because the density of salt water is higher than that of what? Fresh water. The density of salty water is higher than that of fresh water. So the salt particles, when mixed with water particles, make it denser. Make it what? Denser. Okay, how about floating in air? Floating in air, you've seen the floating balloon. These floating balloons. Yeah, if a balloon is filled with a gas, for example, which has less dense or less dense than air, such as hydrogen or helium, it will go upwards. It will float. It will be able to float in the air. Meteorologists use balloons filled with the hydrogen to find out about weather in different parts of the world. Meteorologists are these people who do weather forecast, who can predict the weather of an area. So they use hydrogen balloons, hydrogen filled what? Balloons. So hot air is less than cold air. Okay, and this is because everything expands when it gets hot. So if a mass of air expands, its volume will increase while its mass stays the same, so its density will go down. Hot air will rise. The hot air will rise above the cold what? Air. That is how a hydrogen balloon works. Thank you very much for listening, and then we shall look at relative density of a substance in our